Hello guys, welcome to my YouTube channel. So before going ahead with this video, please make sure that you watch all the previous videos of this chapter, electric charges and field. So in this video, I am going to explain the electric field. So the electric field, this is very important topic in this chapter. The electric field tells us within which region a particle will experience electrostatic force. So we already studied about electrostatic force in our previous videos. When two electrically charged particles interact in empty space, how does each one know that other particle is there? So the concept electric field occurs when there are two electrically charged particles, and between those two electrically charged particles there will be an electrostatic force. So two charged particles, one must be considered as source charge, which create a region around it, and another is test charge. So test charge should be very small compared to source charge. Otherwise what happens? The test charge will have its own electric field similar to the source charge. So more specifically we can define electric field is a region around a charged body in which another charged body experiences an electrostatic force. So consider one simple example. Consider two particles. So suppose Q1 is here, which create a field around this charged particle. Here Q1 is our source charge, and we need to consider another charge Q2 at a distance r from Q1, and Q2 is at the surface of this region created by Q1. So Q2 is within the distance r from Q1. Then Q2 attract Q1. So suppose Q2 is within the region of Q1, then Q1 and Q2 are attracted or repelled depending upon the sign. Whether it is positive, then they repel each other. Suppose positive, negative, then they will attract each other. Suppose consider a scenario. Q1 is here, which has the region electric field around Q1. Suppose Q2 at some distance like this, which is not R, and Q2 is away from the region created by Q1, then Q1 cannot attract Q2, right? So what we can conclude is, if Q2 is at a considerable distance from Q1, or we can say that if Q2 is within the region created by Q1, then there will be attraction or repulsion depending upon the sign. Any charge which comes inside the field, inside this field, Q1 will attract or repel depending upon the charges. We can relate this concept to our Wi-Fi signals. So to provide Wi-Fi network, we need one router here, and router provide Wi-Fi signals for some area. So suppose we can say 5 meter. That is, this router provides Wi-Fi signal within the range of 5 meter. So suppose we hold a mobile phone in this area, our mobile phone can able to access our Wi-Fi signal. Suppose we go ahead, suppose we hold the mobile phone in this area, we cannot access the Wi-Fi signal because the range of the Wi-Fi signal is only for 5 meter. If we go further, we cannot able to access the Wi-Fi network. So this electric field is also somewhat similar to our Wi-Fi network. So this is one of the example. So we can conclude that Wi-Fi signal act somewhat similar to our electric field concept. So this is all about electric field. So, for example, consider an electric charge plus Q which is located at a point O in a space as shown. Okay, so we have to consider one point where plus Q is located. Name that point as O. And if another small positive charge plus Q, small letter q, is placed within the region of capital letter Q, then small letter q will experience a force of repulsion because both these point charges are positive. So both the charges have the equal charges or equal sign. Away equal charges get always equal charges get repelled. So how does this plus q exert a force on this small letter q? The answer is that the plus q set up an electric field in space. So this plus q which is placed at O will set up one electric field in space surrounding it, where small letter q is placed exactly at the surface of the electric field. Then the charge plus q which produces an electric field is called source charge. So plus q is called source charge because this charge set up an electric field around the region, and this small letter q is called test charge, because test charge should be very small, because test charge cannot create a electric field by itself, because source charge can only create an electric field. So if a charge is creating its own electric field, then that charge is called source charge, and every charge which comes inside the source charge and get attracted or repelled is called test charge. Test charge should be very small compared to the source charge. The next topic in this chapter is electric field intensity. So we were much aware of the term called intensity. So we have heard this term in our day-to-day life. This usually we heard as intensity of current, etc. So what this intensity means, what exactly the term indicates, intensity. So this is the state of being intense, or this basically indicate the strength, right? Intensity, the word intensity means the strength. So electric field intensity is the strength of electric field that is described by a quantity. So what is electric field intensity? This is exactly a quantity which represents the strength of the electric field. So we already studied what is electric field, right? So electric field is the region around a charged body. So electric field intensity is nothing but the strength of that region. How that charged body exert the electrostatic force for another charged body. So that indicates the electric field intensity. So we have one charge plus q at a point A, and another charge q is placed at a distance r from A. So electric field intensity is nothing but the ratio of electrostatic force and test charge. So we can define electric field intensity E is equal to electrostatic force is represented by F per unit test charge. Here test charge is small letter q. So q. So electric intensity is a vector quantity. It is a vector quantity. And the SI unit. So what is the SI unit? Electrostatic force SI unit is Newton, and charge has the unit Coulomb. So electric field intensity has the unit Newton per Coulomb is the SI unit of electric field intensity. So this is all about electric field and electric field intensities. And if you have any doubts or queries regarding this topic, please comment down below and I will try to solve in my upcoming videos. Thank you.